This is one energy level of the kingdom of Type 1 in the midst of a harsh winter. Normally, in warmer times, the inhabitants of the kingdom are free to make random movements since energy is plentiful. However, as energy is a scarce commodity now, these movements must be reduced. Edward Koo, an electron, moves through the lattice of positive ions, trying not to collide with them. Up ahead, he notices Edwina Purr moving through the lattice. Her movements draw in surrounding ions, creating a greater positive charge concentration in a small area around her. Edward knew moving through these disturbances would reduce his energy costs, and despite the repulsion Edward and Edwina felt towards each other, they saw an opportunity. If they were coupled, one of them could move using less energy by traveling through the more positive areas the other temporarily made. Edward and Edwina were joined as a Cooper pair and could move to the lowest energy level with other pairs. Before, this was not possible. Having more than 2 electrons on one level would mean there were identical spins within the level, which is against the laws of the kingdom. As a couple, however, Edward and Edwina had a net zero spin, allowing them to occupy the same level as other pairs with net zero spins. These electrons had given up their extra energy to occupy the lowest energy level, so they could not collide with the lattice. Doing so would break the pairs, causing energy expenditure as some would have to move to higher energy levels, a near impossible occurrence when there is no extra energy left. After all, electrons can't go into debt. And so, all electrons moved with zero resistance throughout the kingdom, which became known as the Type 1 superconductor. And now, the story of how the Type 2 Republic became the Type 2 superconductor. Here with us is Dr. Finn Egmoff to explain.
And a Republic of Type 2.
There are currently no explanations for the superconducting phenomenon in the Type 2 Republic.